Simplifying radicals. We're going to simplify radicals by using a couple of properties when necessary. What this property says right here, if you have multiplication, you can separate multiplication by giving each radicand, the numbers underneath the radical are called the radicand, by giving each radicand its own square root. Same is true for division. Now, what we mean when we say a radical simplified, that means that the number, or the radicand, the number under the square root, or under the radical symbol, has no perfect square factors. Now you may be wondering what are perfect square factors. Besides the 1, we're going to consider 4, 9, 16, 25, 36, 49, so on, so on, so on. Now, all these numbers, where they came from, 4 is the same as 2 squared, 9 is 3 squared, 16 is 4 squared, so on, so on, so on. If we take the square root of 4, we're going to get a 2, a plain old 2. Square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, so on, so on, so on. That's what we mean by perfect square factors, and factors divide into. Let's consider this example. Square root of 40. Now, 40 is not a perfect square number. It's not in this list. If you tap in the calculator, you'll get a decimal answer. We don't want a decimal answer unless the decimal is a perfect square itself or has a perfect square factor. What we're going to do is think of factors of 40 such that one of them is a perfect square factor. Now, one approach is, if you can't see what we're going to do, is start listing the pairs of factors that give us 40. Not worried about the 1, since we know 40 isn't a perfect square. We can try 2 and 20. That's neither one of those are perfect squares. 4 times 10. Now that does give us a perfect square factor, because 4 is a perfect square factor. There may be a bigger one. Let's keep on going. 5 times 8, and that's it. Neither one of those are perfect square factors. This is only pairs of factors such that one of them is a perfect square. So we're going to rewrite square root of 40 as 4 times 10. I always like to write the perfect square factor first. And then, using this property, we're going to separate each with its own square root. And then what we're going to do is we're going to simplify. What's the square root of 4? 2. Square root of 10 isn't a perfect square factor, so it stays as the square root of 10. And there's the answer. Now what I'm going to do, I'm going to do a lot of work in my head to show you that you can really break this down and make it even more simplified. Even though this is a pretty clear-cut way to do it, we can actually break it down even more. If you've ever seen the classic Oscar-winning movie Mad Max Beyond Thunderdome, there are scenes in the movie where they're in a cage fighting, and the crowd chants, "2 men enter, 1 man leaves." That's what we're going to do to simplify these square roots, or these radicals. Here we go. 18. 18, square root of 18 is not a perfect square. But 18 does have a factor that is, and that is 9. So we know 9 times 2 is 18. 9 is a perfect square. 2 isn't. 2 men entered. 1 man leaves. The perfect square always leaves. The square root of 9 is 3. The 2 stays. 2 men enter. 1 man leaves. And that's all we're doing. Now let's look at 80. Let me show you 80. This may take a few steps, so be aware of this. I'm going to show you the long way, and I'm going to show you the short way. Now some people immediately know or think that 4 divides into 80. And it does. It goes 20 times. So we're going to rewrite the square root of 80 as the square root of 4 times 20. 4 comes out as a 2. 20 stays. Now some people think they're done. You're not done. The reason why we're not done, the 20 breaks down further. It has a perfect square factor. So what we're going to do, we're going to take this 2 and just write it down again. And we're going to separate the square root of 20, because 20 is the same as 4 times 5. Now, what we're going to do is bring this 2 on down. The 4 comes out. The square root of 4 comes out as a 2. And the 5 stays. Now some people think might think this is 22 square root of 5. It's not. Just like with anything else, if you see a number or two numbers separated by parentheses, brackets, square roots, this is multiplication. So this is actually 2 times 2, which is 4, and then the square root of 5 stays. Now, we could have saved ourselves a whole lot of work. Let me show you what I mean. If we had thought about it a little bit more, we may have discovered that there's a larger number that's a perfect square factor of 80. Look at this 4, for example. If we take the 4 and put it back in, it's got to go back in as a square. What 4 squared is 16. So in other words, what we should have done is think. Keep on thinking. Was there another number that's a perfect square that divides into 80? So we could have tried 9. 9 won't go into 80. We knew that 4 did, but 9 won't. Then we would try 16. Is 16 going to 80? And the answer is yes. 16 goes 5 times. 16 comes out as a 4, and the 5 stays. I'm not sure what that is. So, if you find the largest perfect square factor, it can save you some work. But if you can't, it's still possible. So keep that in mind. Now on this one, first thing I'm going to do, I'm going to use this property. I'm going to separate it into 2 different problems. Square root of 12 over the square root of 49. When I do this one, I always do the easy part first. In this case, the denominator. Square root of 49 is 7. 12 breaks down. It has a perfect square factor, which is 4. 4 times 3 is 12. The 4 comes out as a 2 because the perfect square always comes out, and the 3 stays over the 7. Now if the 2 and the 7 had reduced, we would have, but they don't reduce, so we're done. We can also simplify radicals with variables. Now we're going to keep in mind that the square root of x squared is the positive value of x, so we're going to call it x. And essentially we're going to do what we did in the previous section, if you saw that video. And we're going to divide 2 into 6 because there's an understood 2 outside of the square root. If you want to, put it in there. 2 goes into 6 3 times. Now what happens if it's a 5? This is a 5 right here. What happens if there's 5 or an odd number? What you can do is you can rewrite it as square root of x times x times x times x times x. But as we have seen before, every 2 x's makes a square. That's how we get the x squared times x squared, and then an additional x left over. And then we can separate those each with their own x squares. And then keep in mind, square root of x squared is x, and that's where those come from. That x can't come out, it stays. And then we just multiply what's on the outside. X times x is x squared, with that x remaining on the inside. Now there's an easier way. Watch this. All we really have to do is long division. 2 goes into 5 2 times. 2 times 2 is 4, subtract and we get 1. That 2 stays on the outside, and the remainder goes on the inside. We just choose not to write it, but if you want to, you can. So, let's do this one. I'm going to do it the easy way. 2 goes in 11 5 times. 5 times 2 is 10. Subtract and we get 1. What that means is that this 5 goes on the outside, and since this 2 didn't go into 11 evenly, it means we got an x left over on the inside, and you probably don't want to put that 1. So keep that in mind. Probably don't want to with the system that we use. Let's see if we can do this one. Square root of x to the 9th over 4x to the 4th. Now I'm going to do this one without any steps at all. Let's see if you can follow along. Square root of 4. I'm going to do the bottom. I always do the easy stuff first. Square root of 4 is 2, and that's on the bottom. Square root of y to the 4th just means 2 goes into 4 2 times. Remember, there's a 2 there. Now watch this. 2 won't go into 9 evenly, so that means that I have an x on the outside and an x on the inside. If it went evenly, I wouldn't have to worry about this, but it doesn't. 2 goes into 9 4 times, the remainder of 1. And we're done.